Good afternoon. Hi. Hello. It's very bright. The light's down there. It's difficult making out how many people. But thank you all for coming. My name is Dylan Beattie. I am going to talk to you this afternoon about life, liberty, and the pursuit of APIness, the secret to happy code. This is me. I'm a developer, systems architect. I've worked in all kinds of things. I've been building websites and web applications since 1992, so for about as long as the World Wide Web has existed. Today, my day job, I'm the systems architect at a company based in London called Spotlight. My website is at dylanbeattie.net. I'm on Twitter. I'm on email. Any of these, if you want to follow up, you have any questions or anything you want to ask about or talk about after this. And yes, the topic of today's conversation is about happy code. Now, my company, Spotlight, the company I work for, we work in show business. We have default clip art, like every industry does, and this is ours. These are the Greek theater masks of comedy and tragedy, happiness and sadness. And I've been working with this company a long time. I've worked on lots of projects with them. I've worked on projects with other teams. I've talked to hundreds of developers and teams about things they're working on. And one of the many, many things that I've noticed over the course of my career is I can't think of a single successful project that has been shipped by people who were miserable, people who were grumpy, people who were frustrated and pissed off and didn't enjoy going to work and stuff. I can think of some examples of some incredibly, audacious, ambitious projects, kind of projects you think would fail just from the complexity of the requirements, and yet, someone's managed to ship a really nice, elegant, lightweight solution that solves the problem. I can think of projects that should have been, straightforward, relatively easy, well-funded, good requirements, good contact with the customer, that have kind of collapsed under their own weight, under the weight of the sort of growing pile of day-to-day friction and frustrations. And so I started thinking about this idea. When we build software, we have functional requirements. What does it have to do? And then we have the non-functional requirements, which are things like, performance and monitoring and infrastructure. And I thought, what if we started treating developer happiness as one of the non-functional requirements that we optimize for? What if we look at ways that we can actually build systems that are happy, that make people happy when they work on them? Just to be clear, this is not a talk about mental health. This is not a talk about depression or anxiety or any of, those sort of conditions. I'm talking about just not being pissed off. I'm talking about going into work and getting through the day and coming away and going, you know what, that was pretty good. We did good stuff today, and we're going to go back tomorrow and we're going to do more good stuff. And there are two themes that we're going to talk about in the course of developing this. One of them is this. This is an idea called discoverability. Well, this is the space shuttle, Discovery, but I like space shuttles and I needed a slide. Discoverability is it's an idea that comes from industrial design, product design, user experience design, and all those fields, they have their roots in psychology. And discoverability is the ability of things to be found. It's a combination of things being obvious. It's a combination of that and, signage and affordance, ways you can interact with things, giving people the opportunity to explore systems for themselves and discover the capabilities, the boundaries, the services of those systems. Now, the other thing I'm going to talk about is models of learning, psychology. Me, like, probably many of you, and I think most developers, we enjoy solving problems, we enjoy solving puzzles. And when we do that, when you're trying to work your way through something, whether it's a piece of code or a maths problem or a crossword puzzle, when you solve something, your brain releases a rush of a neurotransmitter called dopamine. Dopamine is the addiction chemical. Dopamine is the thing that gamblers get when they win. Dopamine is what keeps people coming back for more. Now, being addicted to solving problems, I think that's probably okay. Work-life balance is important, but I think, if you get a sort of positive feedback buzz out of doing the work you do and doing it well, then I don't think that's too bad. Now, the other interesting thing about dopamine is studies have shown that things that you learn that are accompanied by this dopamine rush, you will actually retain them. You learn them faster, you retain them for longer, you recall them more quickly when you need to. So if you can build systems that somebody can learn for themselves by experimentation, and every time they learn something, they get this little ping, this little rush of dopamine in their brain, they will be much happier, they will feel like they're achieving things, they will learn faster, they will recall that information more easily, and they will generally find it much easier to get to a point on a new code base or an unfamiliar system where they understand it, they're productive, they can go and they can do meaningful work with it. So while we're talking about learning, I want to just talk a little bit about learning curves. So we have this idea of a learning curve. There are no units on this graph. My high school physics teacher would flunk me for this. But basically, we have expertise is how good are you, how proficient, how competent are you at using some tool, some system. And experience, how long have you spent playing with it. So we got two here. We got one on my right, which is blue. We'll call them the blue one and the red one, so we don't get left and right mixed up. By a show of hands, raise your hand if you think the blue learning curve is better. Okay, that's a good chunk. Raise your hand if you think the red learning curve is better. So that's interesting. Kind of about 50-50. Better is a very subjective word because I haven't told you what metric we are optimizing for here. This steep learning curve is someone teaching themselves Haskell in a long weekend. This is someone who goes very, very quickly from I don't know what I'm doing to okay, I got this. This one is somebody who's been using Microsoft Word for 5 years and they still don't know what a page break is. There are different models of interaction. Now, the thing about these learning curves, the thing about them that's important, it kind of doesn't matter how steep they are, because a very steep curve, some people will just work on it slowly. They will take more time to get there. There are some things you need to avoid, though, when you're thinking about the learning curve associated with the systems you create. This is a localized peak. This means somebody has invested some time and effort. They've learned all this stuff. They get to here, and they're like, I'm stuck. I can't actually get better because what I've done here, I've developed this mental model or this body of knowledge, which is actually now going to break down. This is ASP.NET Web Forms, where you spend 2 or 3 years and you get really quite good at building these interactive websites with buttons and things. And then you need to do something like build some streaming media with a continuing download, or you need to build something that uses richer HTTP verbs. And suddenly you realize that you need to be over here. You need to be learning the fundamental architecture of the web. What you have learned instead is a very, very leaky abstraction. You've learned somebody else's model of how they think this is supposed to work. And in order to actually make progress, first you need to unlearn all the stuff that you learned there, and then you need to work your way all the way back up the other side. And, this pisses people off. You get to a point where, well, if it was wrong, why did I spend the last 6 months learning all of this kind of stuff? And this is something that happens a lot. There are lots and lots of frameworks and abstractions and things that we as software developers use to get up and running quickly. And there is always a risk when you're learning something, you start with abstractions. We start off, if you study physics in school when you're a child, you learn a relatively simple conceptual view of the universe. If you go on to study at university, they say, well, most of the stuff you learned in school is kind of right for, big things, but actually when you get down really small, we have this thing called, quantum physics, which is different. The abstractions break down. And that's kind of okay because the abstractions work most of the time. What you want to avoid are this thing where you have a learning model that teaches people the wrong thing. It teaches them something that they're actually going to need to come up with a completely different way of thinking once they take the training wheels off. Then there's this. This is the learning curve with the brick wall in it. This is the point where you are learning Haskell or F# and someone says, oh, let me tell you about monads. And 2 days later, you're just going, and they're already up here. They've forgotten what it's like to be down there. And you're down here going, guys, help. I cannot see how to make the conceptual leap from where I am to the next level here. This is one of those things where you're following a walkthrough. I remember years ago, I was trying to get a sound card working on an early build of Linux. And it's like, do this, recompile the kernel. And I was like, okay, so step 1, 2, 3, step 1, draw the eyes. Step 2, draw the beak. Step 3, draw the owl. And, it's that kind of model. And this is effectively not a learning curve at all. What this is you can get this far, and then if you can find your own way to here, you can get this far. So think when you're building systems, things people are going to interact with, think about this idea of learning curves and think, where are people going to get stuck? What are the points that you got stuck? Where did you have trouble when you were first putting this stuff together? Now, many, many years ago, in the ancient early days of .NET and alt.NET, when we were stealing things from Java and it was all very interesting, I was playing around with IOC containers for the first time. And I downloaded Castle Windsor, I installed it, and I did what I followed a blog post. We didn't have Stack Overflow then, it hadn't been invented yet, so you had to do everything using expertsexchange.com and blog posts. And I installed it, and I pressed F5, and I got the yellow screen of death. And I thought, and then I looked closely, and it says, this is not null reference exception. This is not invalid operation. This is, hey, it looks like you forgot to register this module. To fix this, add, and then it gives you the XML that you need inside the error message. So literally, you've hit a brick wall, you're stuck, but the people who built this framework are like, this exception is probably going to happen because somebody forgot to do a particular thing. So let's help them out. Let's put the next clue they need to keep making progress right in front of them. The error message, this stage is very wobbly. The thing that actually says you have a problem also tells you, and here is how to fix your problem. So, I've talked a little bit about this idea of user experience and user psychology. And a lot of you out there are probably thinking, well, UX is all okay, but I'm not a UX designer. I'm not a UX developer. I'm a database engineer. I build back-end systems. I build APIs. I'm a systems network person. We all have users. If the thing you build is going to get used by anybody for anything, you have users. If you're building back-end frameworks, your front-end developers are users. They are using your work to achieve something, to do their job. If you're creating networks and virtual infrastructure, the people deploying applications onto your stack are your users. If you're designing databases, unless you're just designing databases for fun, somebody is going to connect to them and go in and try and get data out. Those people are your users. And we have this wealth of patterns and practices and techniques in user experience and product design. And so what we're going to do today is talk about how we as developers can take those patterns and we can apply them to the work that we do, so the people who use our work will go home on time with a smile on their face, they'll come back tomorrow, and we'll start achieving some good stuff. And we're going to start by telling a story. So you join a new team. And your first day on the team, whether you're going to the office or you log in remotely from wherever you're working, and the first thing on your to-do list is, hey, you've got to get the website running locally. And you think, okay, how hard can that be? So you go into the GitHub repository, and you search for website, and you don't really find anything. So you search for web, and you find web and web_final and web2, web 2015, web 2016. And you look around in a couple of these repos, and you're like, I'm not sure this is the right place. And so eventually, you ping somebody on Slack, and you say, hey, the website, which repo is it? And they say, oh, it's in the repo called sales application. And you're like, what? And like, yeah, IT used to be part of the sales team, so it was in sales application. Don't worry about it. So, you get some code, and you check the code out, and you open Visual Studio, and, you press F5, and it just fails. It won't build. And so you're like, okay, and you go digging, and you're like, oh, it's looking for C program files, my company, assemblies, version 2, 2016, foo.dll, which of course isn't on the internet because it's proprietary. It's something that came from somewhere else in this company. So you go to someone else, hey, where can I get this foo.dll that it needs? And they're like, oh, yeah, of course, here, copy all the DLLs, just copy my entire C drive, and you can cherry pick the bits you need. And, you get it up and running, and then you finally run it, and of course it crashes because you don't have a database, and you're like, where do I get the database from? And, if you're lucky and your coworkers are patient, you can maybe work through the whole thing and get something up and running, and you're going to leave at like 9 o'clock at night, and you're going to be tired. And if you're unlucky, you're going to get one of Drunk Visual Studio's greatest hits. You're going to hit a brick wall, You're just going to get, they're trying to do your job, trying to get it up and running on this new team, and you're just going to get unspecified error. And, at this point, you're like, hey, does anyone know about unspecified error? And they're like, which one? There's like 25 that we know about. And you're like, are they documented anywhere? They're like, oh, no. Go and ask John. John's the unspecified error guy. And so if you're a good developer, you'll think, all right, come on, this is crazy. Let's fix this. So you'll open a page on the wiki, and you'll go through the steps. You'll be like, get these DLLs from here, and go through and install the database, and clone this database from this repository, install this code, do all these things. And then, you start off miserable. You think, I'm going to fix this. Yay, happy, wiki page. And you come back 2 weeks later, and the build process has changed. Some of the DLLs have moved. The people who did it don't know about the new wiki page. It's unsustainable. This idea of having to retrospectively play catch-up with a constantly evolving code base full of chaos just doesn't work. It doesn't scale. It doesn't create happiness. So let's tell the same story all over again. You start a new company or new team working on a new project, and they're like, hey, you've got to get the website running locally. And you're like, OK. And they say, by the way, the code name for the website is Applejack. And you go, isn't that a My Little Pony? And they go, yeah, it doesn't matter. It's a code name. Type that in, you'll find it. So you go into GitHub, you type Applejack, and bang, there's one repository called Applejack. That's got the website in it. And you go and look on the wiki, and you type Applejack into the search box, and bang, you get project pages, Applejack. This is everything we know about this project. So you check it out, and you press go, and the first thing it does is restoring Nuget packages. And you look at it, and it's pulling in jQuery and .NET Core and all these, and then you notice it's pulling in a bunch of packages called mycompany.foo.dll. Because someone has gone, we've got all these proprietary assemblies. Why don't we set up our own Nuget server and put all our assemblies on that server so we don't need to worry about finding them on someone else's C drive and copying them across? So clone code, press F5, that gets you as far as the application has built, starts to run, and it pops up a screen going, hey, looks like you're trying to run the application, but you don't have a database. Go and look in your checkout folder, in your source code folder. You'll find a folder in there called SQL. If you run the scripts in that folder, we'll create a local database you can connect to. Now, this has achieved two things for you. One, you now have a database, but also you know where the database creation scripts are because you've just solved a puzzle. You've got that little ping, dopamine, hey, look, I made it go. I made it work. I made the machine do what I want. And next time you're like, hey, I wonder what the table definition for this is, or I wonder how this data gets populated. You can go and jump into that folder that you remember is there, and you can pull those scripts out and find it. And by the end of day one, you've got the website running, you've got the database running, you kind of know your way around it a little bit, you found it on the wiki. Happy, Now, Applejack's a code name. It doesn't matter. Naming things is important. If you have a kind of a natural domain boundary, if you have some project in your application that in your organization that has some code that goes with a database and maybe it goes with some logging infrastructure, give it a name. It doesn't matter what the name is. It really doesn't. We're not naming a product here. We're using a code name. And by giving it a name, you cut out a lot of unnecessary noise. When something goes wrong, you've got email alerts or you've got WhatsApp alerts or whatever coming in, use the product name. Applejack just had a problem. Applejack says it's at 90% CPU. Applejack is reporting unusual numbers of API timeout exceptions. It's progressive. Once you know about Applejack, that gets you into the code. The code will then get you into the Nuget repo. The Nuget repo will build you the solution. The building solution will point you at the database. The database will point you at the schema and everything. So every step, the code that you're running, the work that the other developers have done, they've laid this groundwork for you. That means you get this very smooth, organic, satisfying progression from, I have no idea what I'm doing, to, hey, this is cool. Tuesday morning you come in, you might even deploy something to production. Now, the first computer I ever had it wasn't this exact computer, but it looked like this computer. It was a 286 PC. It had 1 megabyte of memory, whole megabyte. And when you switched it on, it would sit there and it would go for about a minute, and then it would go, and you'd go, hello, and it would say bad, command or file name. And you would go, sorry, menu, because some computers had menus, and it would go bad command or file name, and you'd go help, and it would say bad command or file name. The only fun thing you could actually do with this MS-DOS prompt was you could say, if you're happy and you know it's syntax error, and it would say syntax error. If you're happy and you know it's syntax error, and it would go round and round and round. But apart from that, Now, at this point, what do? You've got this little blank thing here, and you're thinking, you have to go and look in the manual. And the manual starts with, welcome to the Microsoft Disk Operating System, blah, blah, blah. And you're like, there's no affordance. It's basically a brick wall. It's like, here are all of the things that are available. They're all listed in this manual. Eventually, you find, like, dir, will give you a directory of what's on there and everything. But literally, you've just bought probably the most expensive machine you've ever owned. You've plugged it in, you've switched it on, and it just goes A. And, where do you go from there? And anything you type, it says bad. This is not a way to, create a happy experience. Now, the other computers that you could buy around the time that my 286 PC came out were Apple computers. And when you switched them on, they did this. They showed you a little picture or a little cartoon of the thing you just bought. And then they said, welcome to Macintosh. And they sat there, and they kind of sang away happily to themselves for a couple of seconds. And they're showing you little pictures. And the pictures look like the things you just took out the box. There's a picture of the computer, and there's a picture of the disk. And, there's still a little bit of startup, a little bit of warm-up time while it's doing its thing. And then you get this. Now, the first thing you notice is, oh, look, there are things here. And I can move this mouse around. The mouse was kind of shaped like something you could grasp with your hand. And you'd move that around, and you'd click on stuff, and you go, oh, when I click, these things appear. And you had this thing here, system, and that looks like the disk that you just took out of the box. And this down here, trash can, looks like a trash can. So you're like, okay, well, that's probably where I go to get rid of things. We won't talk about the fact that to eject the disk, you drag it to the trash. That was one of Apple's weirdest user experience quirks. So, I love this idea that as you start interacting with an unfamiliar system, it gives you clues and cues and helps you do it. And my absolute favorite example of this that I've ever come across is this.
Good morning. You have been in suspension for 50 days. In compliance with state and federal regulations, all testing candidates in the Aperture Science Extended Relaxation Center must be revived periodically for a mandatory physical and mental wellness exercise. You will hear a buzzer. When you hear the buzzer, look up at the ceiling. Good. You will hear a buzzer. When you hear the buzzer, look down at the floor. Good. This completes the gymnastic portion of your mandatory physical and mental wellness exercise. There is a framed painting on the wall. Please go stand in front of it. This is art. You will hear a buzzer. When you hear the buzzer, stare at the art. You should now feel mentally reinvigorated. If you suspect staring at art has not provided the required intellectual sustenance, reflect briefly on this classical music. Good. Now please return to your bed.
That's from, anyone want to tell me what that's from? Portal 2. And it is the training level you get when you first start playing the game. And in the course of that little skit there, so one, it's actually got some laughs and some narrative and some story. It establishes some context. It also teaches you how to look up, how to look down, how to walk, how to move around, how to interact with objects that exist in the game. And it does it in a way that, you're laughing and you're entertained, you're happy, and you're learning. And the things you're learning there are going to stick. And if you get it wrong, if you stand still for too long, the machine will actually pop up and or your computer will say, hey, use the mouse to look around, move the mouse to look up, and it will tell you which keys and how you go through and perform these interactions. So those are a couple of neat examples of this idea of discoverability and systems that will help you discover them one step at a time. I want to show you one now, which is a recent sort of very developer-centric example. This is from Microsoft Edge, the new, we're not going to do Internet Explorer anymore. It's called Microsoft Edge now. And the first time you run Edge as a web developer, you go and you bring up one of your sites that you're working on, and you go, right-click, I want to inspect an element. Right-click, and all you got is select and print. And you're like, where's my stuff? I'm a web developer. I can't work with select all and print. And so you start poking around a little bit, and you go up to the context menu here, and this brings up a list of things you can do. And one of those things is called F12 Developer Tools. So first of all, you're like, F12 might help with this, because none of the others have a key next to them. It's like saying, we're special, you and me. We can do function keys. Doesn't for the other losers, function keys are special. You set it, and you get a thing pops up that says, inspect element and view source will now appear in the context menu. Now, I love this. 90% of people who use a web browser don't need right-click inspect element and right-click view source. You ever had a panicked phone call from a family member going, I right-clicked the internet and everything broke, and now I can't see any pictures? And you're like, what does it look like? And they're like, there's lots of funny angly brackets. And you're like, yeah, it's all right. It's fine. Don't worry. Don't panic. I think this is a really nice way of kind of taking the stuff out of the way of everyday users. When they right-click, they select all and print. That's probably what most people need. But if you are a developer, you go in, it takes you a little bit of exploration. You go and click this menu. You're like, OK. And so by the time you've done that, one, you've got it in the context menu. Two, you've realized that most people don't have it in the context menu. Three, you've learned that you can use F12 to activate it. Now, this idea of discoverability, of capturing the exact point where somebody is interacting with one of your systems, is an incredibly powerful pattern that we can apply in all sorts of situations when we're building code. So there is a thing called intelligent code completion, what Microsoft call Intellisense. You typing away in your editor, and you type something, and you get these little pop-ups that say, hey, these are all the options that are available. This is where you can go from here. These things are, signifiers. These are the options that are available. And, I'm sure there's some of you thinking, is this guy really telling us about Intellisense at NDC? What does he think we are? We've all used Intellisense. Anyone who's ever used an editor that has code completion has worked with these kinds of things. But how many of you, when you're building your own code, when you're building libraries and applications, actually stop to think, hey, maybe I could put some smart Intellisense in here that will help other people make sense of this code base that I'm creating? There is this really quite cool pattern that exists, which is something called Fluent Interfaces. Now, what you can do in C# and a lot of other languages is you can define extension methods. You can take objects, classes, and structures that are built into the language, and you can extend them. So we can do things like, now don't do this, because this is a little bit weird, but I just want to show you the thing. We have a method here that will take this int, called value, and it will return timespan.fromMinutes, and it's called minutes. And then we are going to create another, so we've got an Intellisense prompt here. This returns a timespan equal to the specified number of minutes. Number of minutes returns a timespan, an instance of cref equals timespan. So by doing this, we've created context, we've got Intellisense, we've got documentation that's going to pop up when someone uses this, and when someone types 20 dot, they can see here, bang, 20 minutes. And now, this actually was an experiment. There's a lovely idiom that Ruby uses for calculating timespans and data arithmetic, which is you can build extension methods where if you want to say 20 minutes ago, you say 20.minutes.ago. Because that's nice. It's unambiguous. It's readable. And using .NET and extension methods in C#, you can do exactly the same thing. You can have an extension on integer that turns it into minutes, and you can have an extension on timespan that will subtract it from now, from the current date time. So subtract this timespan from the current date time, return the result. And so now, by just putting a couple of extensions in on this language, we can write code that reads 20.minutes ago, as opposed to datetime offset.utc now.subtract timespan.from minutes bracket 20, or whatever the syntax might be. And once we've got this in there, one, you type 20 dot and you get Intellisense popping up. And two, you can see from the Intellisense, from the intelligent code completion, what this is actually going to offer you. So this is, as I said, it's a pattern called Fluent Interfaces. It's a very good way, if you're building APIs that expose things like configuration properties for configuring something like a pipeline. If you have a request going through a system and you're like, okay, well first we need to run all the incoming messages through a validation filter. Then we need to run them through an authentication filter. Then we need to run them through a parser. Then we need to run them through something that transforms them. You can use these kinds of Fluent interfaces. So you've got, filter.message.authenticate. And that then will say, okay, what is available after you've authenticated? Well, after that, we can run it through a transformation. After the transformation, we can run it through a response processor. There is something that we do all the time in .NET, which is connecting to databases. And I've been writing .NET since Visual Studio .NET Beta 2, and I still cannot write a SQL connection string from memory. I do not know the syntax. It just will not stick. So every time I go new SQL connection, at that point I hit a brick wall. It disrupts the flow, yanks me out of the zone. So what if we wrote an extension method called SQL.connect, which tells you in the Intellisense, the thing that pops up at the exact moment you get stuck and says, hey, the thing you can never remember is this. This is how you go in and connect to it. Now, I love these kind of ideas. I love this approach of thinking, where are people going to get stuck? Where are the roadblocks? Where are the brick walls? What are the dead ends in this application? And when my users, in the broadest possible sense of the word, reach one of those dead ends, how can I help them out? It's not just about dead ends. It's also about helping people explore and discover what is available in the scope of a system. So we have a pattern in UX called, signifiers, signage. We're all familiar with signposts. You're out on a walk, you're in a park, and you're like, hey, where can I go? What are the things that are available from here? And the World Wide Web, one of the reasons it works and it's popular is it uses something similar. You can have a page, and a page is a collection of, or has a collection of links, and each of those links will take you to somewhere else. And, the web is quite popular. It works pretty well. We can use the same pattern, this hypermedia pattern, in the way that we design APIs. If you're building web APIs or hypermedia APIs that other people are going to use to interact with your data, there's a couple of things you can do to make this experience really good. One of them, use discoverability. But also, you can provide ways that other people can actually play with your data and explore it for themselves. So this is a snippet from a production system that we're working on at the moment. So this is an interactive explorer. Our API ships with some JavaScript. You can open it in an ordinary web browser, and you can switch here between the test environment and the live environment. Test environment gets reset every night. We say to people, this is safe, go and do anything you like. Delete records, we'll fix it in the night, it doesn't matter. And what we do here is we take the raw JSON that gets exposed by that API, but we actually then process it on the client so that all of the different interactions, if there are resources available from here, we make them clickable. If there are actions available from here, so we have a resource here, we have a performance profile, you can go and change their height by doing an HTTP put. So there's the put there, and the person who's trying this out, they don't have to write code and configure it and put the credentials in. Someone says to us, how do I use your API? We say, you got a username and password? No, okay, we'll set you one up. Then go here. Go to developer.spotlight.com and play. Everything that we support, we expose on this interface, and you can actually go and play around with it for yourselves. There's a live environment on there you can use for diagnostics and exploration, and there's a sandbox environment you can use to try things out. If you've got something in your code and you're like, this probably should be working, come and try it on our system. We can replicate the same requests, you can do the same responses, see how the thing actually works. Giving people a safe place to play and clues as to what operations and things are available is one of the absolute best ways of them feeling like they're in control of this journey, this learning experience they're going on. Now, the next part of this talk, the last part of the talk, what I want to talk about is monitoring. So, we've built code. It's great. We learned it. New people are up to speed on the team. The API client developers are happy because everything is explorable. We've got signifiers, and we've got affordances, and we've got discoverability, and the system is running, and everything is happy, and then, something goes wrong. The hypothetical red telephone rings, and there is a problem. And someone says, pick the phone up, and they say, the system's broken. And you're like, what system? The system with the computer. And you're like, okay, hang on, yeah, let me take your number, I'll call you back, hang on. The other line's ringing, you put that down, pick up the other phone. Someone's like, yeah, system's not working, there's a problem. And you're like, is it, can you tell me what it is? And they're like, no, it's not working. And you go through half a dozen of these. Eventually you talk them through how to take a screenshot and email it to you, and they send you this. And you're like, okay, that really doesn't help at all. Somewhere in our application stack, which at last count is 1.5 million lines of code running on 26 different servers, something has timed out. We know it was a request, so hey, maybe that's a clue, What do you do? How do you begin investigating these kinds of problems? You have nothing to go on. people are already upset. Your users are already angry because they were trying to use your system to do some work, and suddenly they're just getting this yellow screen with request timed out. You've got your boss going, how long is it going to take to fix? You're like, well, I don't know. We got 1.5 million lines of code, and I can probably read a line of code every 8 seconds, so you do the maths, you know. This doesn't help. This is a horrible, horrible situation to be in, because when you get to that exception timeout, you know, it's a brick wall. The learning curve is broken. There's no way you can go from there other than just start digging through every single line, every single configuration. What we want to do is not only to create discoverability and, you know, these learning curves and user journeys for people working on our code, we want to create them for people who are running our code, for people who are managing our infrastructure. Now, one of the simplest things you can do with this, take whatever you're running in your organization, try and break it down into a couple of high-level manageable components. Maybe it's as simple as we have a website, we have a database. Okay, so put them up on the wall. Put up a screen, get a spare monitor, buy a TV, come up with some monitoring software, and think, what's the simplest thing we can do? Okay, how do we test if the database is up? Select one from users, bang. If that query succeeds, it's a start. If that query fails, we know we have a problem. You put up another one next to it. How do we know that the website is working? Well, let's do an HTTP GET to our homepage. If that comes back, then, you know, and what you want to do is create early visibility. If something fails catastrophically, it's going to take the entire system down with it. Whereas if one component fails catastrophically, your website goes down, but your database is still okay, you're going to get one green light and one red light. And you can ignore the green light because you know the database is all right, and you can immediately start looking. You've cut your problem size in half because you know the problem there is something to do with the web application code. And you can get more granular. You know, you break it down into, okay, well, actually our website, we have the content management system, and we've got the My Account management system, we've got authentication. So let's make that 4 red lights. And then when someone has a problem, you're like, okay, looks like the login system's having a problem. Create these kind of high-level views, because every time you can partition your system, you know, for maximum points, each of these little colored boxes has a name on it. This one here is Applejack. Applejack is having a problem right now. And you know what Applejack is because you remember from your first day where you got everything up and running. And so even if you're not working on that project right now, you can jump in and find your way around it. So we see we have a problem here. We go into Applejack, we pull the code down. We're like, okay, we're getting a 500 error system. So the next thing that we are going to do is we are going to build visibility into the applications themselves. You know what your app does. You know that it connects to a database. You know that it maintains some internal state. It processes orders. Why not build in a page, stick it behind a password, or use some kind of authentication, lock it down with a firewall, that actually is like lifting the hood, you know, popping the trunk on your, the bonnet on your application and going, what's actually going on in here? That gives you fantastic visibility on what's going on. You fire up, you know, logging infrastructure, you have a look at the dashboard, you see what's happening, you're happy. You haven't had to read 1.5 million lines of code, you managed to hone in on the problem quite quickly. Now, there is an art to exposing this kind of data. You know, complicated systems have lots and lots of features. If you just expose all of them, it doesn't actually help anyone achieve anything at all. This is Visual Studio. Look how easy it is to use. All you need to do is click the buttons to make your program, right? You don't want to expose this. You don't want to expose every single gritty detail of your application. What you want to do is to create transparency, to encourage visibility and a sort of high-level view on what you're doing. You think about the dashboard on your car, it doesn't have a light for every single moving part in your vehicle. It's got, I don't know, maybe 5 lights. You know, there's a problem with the battery. There's a problem with the brakes. There's a problem with this, the headlights are on, and there's that little electrical light that says, take the car to the garage and give them a lot of money and they'll fix it. And that's the kind of level, you know, if it's a problem with the oil, you can put oil in. If it's a problem with the brakes, don't drive it, you have a problem with the brakes. Problem with the battery, get a new battery. If it's the other light, you're going to need to call in the experts. And you can, once you've sort of got these monitoring systems, these dashboards, put them right where everyone can see them all the time. The Starship Enterprise and Star Trek Next Generation, the warp engine that drove the thing, which I think actually the production designs, this is a massive tank full of gin and tonic with an ultraviolet light at the bottom, which is what gives it that lovely blue kind of space glow. You know, it's right smack in the middle of the room where everyone can see it. And there's episodes of that show where one of them will walk past it and go, hang on, that doesn't look quite right. That's the kind of thing you want to do. You want to put this stuff where people walk past it. So if someone's on their way to a meeting or they're going out to get a sandwich, they're like, hang on, one of those lights has just gone red. Or it's gone orange, you know. If it was red, you should have notified someone. If it's orange, they're like, let me check. Might be something that's about to go bad. We can preemptively fix it. There's 3 things that you want to make as visible as possible in terms of your dashboards and transparency and monitoring. One of them is what code, what's the state of your box? What is running on it? What have you put there? What's been deployed? What's it doing? What configuration are you running? There is a web framework in .NET called Nancy. And one of the many things that I love about Nancy is it has a dashboard built in. Any Nancy application, if you go to mywebsite.com/_Nancy, put in the password you configured in your config file, it basically takes all the panels off and it says, hey, here's what's going on under the hood. You want information about your current configuration? Yeah, click the big I button, and we will dump everything. We'll dump the static config, we'll dump the dynamic config, we'll dump what actually happened when the application got bootstrapped. You want to look at diagnostics? They're built in. You want to see what requests are flowing through the system? Switch it on, wait 2 minutes, we'll keep track of them for you. You can see what's actually happening in production. You want to see the settings that are currently in effect? Yeah, we've got an icon for that as well. You can build these things into your apps without a huge amount of difficulty, because you know what your apps do. You know the numbers that are important, and the metrics that are important, and the latencies that are important. So why not track those, capture them, even if it's just the 10 most recent ones. Stick them somewhere where you can put them out on a web page. Anyone with a browser and the credentials can go in, they can have a look, they can see what's going on. The second thing that you want to know is you want context. You want to understand, is the thing that's happening right now, is that a freak of nature? Is this a weird event, or is this just routine? Now, you get a phone call from someone, and one of your network engineers comes up and says, hey, the database server CPU is hitting 100%. That gives you one data point. It gives you this. Bang. So that's your graph. That's 0. That's 100. Database server. Was there a question? No, it's them. Database server's just hit 100. Now, scenario 1, your database server is doing this. Because every hour, someone's running a batch job that's causing the CPU to spike. Scenario 2, your database server is doing this. It's been building up slowly over the last couple of days, and now it's hit the endpoint. Scenario 3, your database server has just done this. Ding, 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 bang. If you don't have historical context, if you don't know what it has been doing for the last 24 hours or for the last 7 days, you have no idea what kind of failure mode you are looking at. Because those 3 lines there, if all you have is the one data point, you're starting from scratch. You're like, will someone get on the box and tell us what it's doing? And they're like, we can't get on the box. Why not? Well, the CPU's at 100%. It won't let us log in. Whereas if you've got these graphs, you can very, very quickly look at that and say, okay, this is, what did we deploy here that has been slowly ramping up? And why didn't we notice at this point that something was eventually going to exceed capacity? If it's this one here, you're like, what are we running every hour? What's taking so long? What's happening? Do we have a stuck payment batch? Is there a bunch of outgoing email that's stuck in a loop or something? And if it's this one here, you're like, okay, who deployed something? What did you do? Has someone just shipped infinite loops into one of our stored procedures or some such thing? This graph here, this is a real trace of our production SQL Server box over the course of 24 hours. And you can see from this graph when everyone in the show business industry in London gets back from lunch and starts working hard. And then you can see where they all slope off to go to the theater or go to the pub. And this happens every day. We have quite a localized industry. A lot of our traffic comes from the UK, and most people use it within office hours. And so if we get a sudden database spike in the afternoon, what we want to know is this weird? Because afternoons tend to be a busy time for us. We got a lot of historical context to support that. If we get a database spike at 6 o'clock in the morning, that's interesting, And having this kind of context means you can very, very quickly determine, is this something sudden? Is this something that is recurring? Is this something that we've been approaching over time? The point about the context is that you need to know here, at the beginning, that you're going to want it here 2 weeks later. Because 2 weeks later, you can't go and recover it historically. So put it in from day one. Log things, monitor things, CPU, memory usage, disk usage, network latency, how much bandwidth you're consuming. There's a lovely saying from Etsy, if it moves, log it. And if it doesn't move, log it in case it starts moving. And that brings us on to logging. So we've got the state of the application, what code is running, what version, what assembly. We've got its impact on the infrastructure. What's it doing to our disk, to our network, to all of these bandwidth, latency, these kinds of things. And then we've got what is the application actually doing? And the best way to do that is to ask it. Now, there's two secrets to getting logging right. One of them, as soon as an application has logged something, get it away from the application and into something central. There are two reasons for doing this. One is the number of people who've ever had a web server crash because the IIS logs had filled up drive C. Anyone else? Yeah. Lots of us have been there. You switch on logging, you forget about it, and a couple of weeks later, it's like, what happened? Oh, 0 bytes free. Why? C inetpub logs is now 800 gigabytes. Oh, cool, all right. So we've written down every single request that hit our website in a folder somewhere that no one's ever going to look at, and the only tangible effect is to take our website offline. Good job. Get them off. Get them somewhere where you can actually look at them. Get them onto some kind of centralized logging, and it doesn't matter what. The one we use is a company called Log Entries. There's one called Logstash. There's Kibana. There's Splunk. There are dozens of these. You can roll your own. You can get them as software as a service. You give them MasterCard. They give you good stuff. There are lots of ways of doing this. Get those logs centralized, because that way, instead of having to go through 20 servers looking for the one that had a problem, you can find the problem, and that'll tell you which one of them, which server you need to go and investigate. Or, if you're doing cattle, not pets, it'll tell you which server you need to take outside shoot and spin up another one to replace it. Depends on your resolution strategy. Now, if you're going to do this across multiple applications, multiple teams, you need to have some consensus among your team about what the different levels of logging mean. We have a convention which dates back to Apache that there are 5 levels you use when logging information from your application. Fatal, error, warn, info, debug. Red is the most serious, blue is the least serious. Fatal means application is completely unresponsive. This is the way my team and I work with this kind of stuff. These are the conventions that we use. If you have your own, that's fine. Just make sure you're all using them the same. Everyone who's writing to your logging infrastructure should agree on what these different levels mean. Fatal, for us, means game over. It means something's gone down, everyone stop what you're doing, work out what has just happened. We've lost something significant. Fatal errors, they should not happen very often. They should never happen twice for the same reasons. That means something went wrong that knocked out your entire operation, and you fixed it, and then it happened again. It makes you look stupid. Don't do that. Fatal errors, these kinds of things, should be followed up. Have an incident report. Have a post-mortem. Sit around. What happened? Database server went down. Why? If anyone's in the keynote this morning where Louis C.K. is doing the 5 whys, website's offline. Why? Database server's unavailable. Why? Because it ran out of disk space. Why? Because the temporary database exceeded the size of the disk. Why? Because it turned out we weren't backing up our transaction logs properly. Why? Keep pushing till you get to something you can fix. Okay, we're going to ship the transaction logs into an S3 bucket every night. And we're going to put a graph on it so that if it looks like it's happening again, we know about it before the system goes down. Errors and warnings. These will happen. With the best will in the world, software has dozens of dependencies that are beyond our control. Now, the way I tend to think of these, an error can be something one person maybe noticed, maybe didn't, but it wasn't that big a deal. It could be something that is, affecting a single customer in your organization. There's one person who's having trouble logging in because their username has got extended ASCII characters in it and there's some validation blocking it. Log that as an error. Go and investigate. These things, keep an eye on them, but they don't necessarily mean drop everything you're doing. Warnings, nobody noticed, but it's still odd. So a great example of somewhere you log a warning, you're doing a checkout, an online order for something, you're trying to convert euros into krona using online exchange rate system, and you don't get a response back. So you fall back to the cached response you had last time, which is 5 minutes old. That's a warning. You try again, the next customer comes through, you still can't get a response. That's another warning. Next one comes up, it's back, the system's available again. Okay, fine, keep on tracking. That's not a big deal. Warnings are like people wearing fancy dress on public transport. You're going to get one or two, they're not a big deal. If you get this, this means something is going on and it might be interesting. You'd probably better have a look just in case. Don't panic, but something interesting is happening. Info. Info means everything is fine, you know. Info is what we use for things like application startup. It's what we use for routine events like, you know, recycling a cache, you know, cleaning up, doing some routine maintenance on disk caches or that kind of thing. In a perfect world, info is all you'll ever see. Now, the biggest value for me in info, say you come back from a long weekend and you're like, hey, there's nothing in any of our logs for the last 72 hours. Now, if all you're logging is warnings and errors and fatal messages, you can draw two conclusions from empty logs. One of them is absolutely nothing went wrong at all over the entire long weekend. The other one is that your logging infrastructure failed on Friday afternoon and everything has been going wrong and the errors have just been disappearing. Info gives you that kind of sanity check. It gives you reassurance. You're like, it's unusually quiet today. You jump onto log entries, whatever. You're like, no, we got info messages. Everything's running. It's just, you know, it's a quiet day. Finally, debug. Debug is the line-by-line, method-by-method, gritty detail of all the stuff that developers put in when they were trying to work out how to make this thing behave in the first place. Debug is the call-by-call. This customer accessed this endpoint with this authentication token and these credentials, and they tried to run this command. One of the best habits that I think we can get into as developers, when you spin up a new application and you get to the point where you're about to go console.writeLine to start giving you some information to work with, stop, install a logging framework, start using log.debug instead. Use that for all your diagnostic output. Use that for your investigations. Use that for your experiments. And then log all the things, you know, just anything that's interesting. If it's interesting enough that you want to read it, debug it. All the things? Yeah, all the things. Because when you deploy your code to staging in production, you can switch debug off. You can have rules that say, okay, fatal, send it to everyone's cell phone and WhatsApp and put it on the big screen and, you know, do SNMP, network broadcast alerts, all kinds of stuff. Errors and warnings, maybe if you get more than 100 in an hour, send somebody an email. Info messages, just leave them in log entries where they're safe. Debug, throw them away. Ignore them. We don't need them. Because sooner or later, there is going to be a problem that you cannot reproduce on your workstation, and it doesn't happen on dev, and it doesn't happen on staging, and it only happens when real production customers are using your system in the middle of the night, and at that point, you are going to want to switch on debug traces, and you're going to want to see what's actually happening with real people getting these mysterious error messages you can't track down. And that will make you very happy indeed. So, let's recap the rules of happy code. Number 1, Applejack. Give things a name. Names are signifiers. Names define boundaries. Names give you your first clue. Giving something a name means people have a way of finding it. They can search code. They can search wiki. They can search logs. They can configure alerts. Naming is good. Pick a naming convention that make it silly. Name it after cities. Name it after My Little Pony. Name it after cartoon characters. Anything that works. Don't worry too much about names. Daft names are fine. Eventually they'll stick. 2, learning curves. Steep is fine. Shallow is fine. Keep them smooth. No brick walls, no localized peaks, no gaps. Think about, as people start working with the system I'm creating, where are they likely to get stuck? Where are the dead ends? Where are the roadblocks? Where are the bits where I really had a problem when I was building this? Because those are probably the places where the next person to come along, your users, are going to go, hey, this has suddenly got really hard, and think, what can you do in that context to help them out? When your system fails, you know better than anybody why you just threw an exception. Or assuming that you're throwing exceptions and not just ignoring them and discarding them, you know why that exception happened. You know, file not found. Well, you're the one who knows what file you were trying to open and why. So why not wrap their exception, the file system exception, in one of yours that says, hey, you know, we were trying to render a thumbnail of this image, but then we went and looked and this file wasn't available on the disk. You know, give them the context. Don't be drunk Visual Studio. Unspecified error. I was trying to install Visual Studio 2017 on a workstation, and I got a dialog box pop up that said, the installation could not complete. Please correct the following problems before continuing. And then it had a list box, and the list box had one word in it, which was Asia. And I was like, that, China, the Middle East peace process, Afghanistan, Pakistan, I'm not doing your dirty work for you, Microsoft. I don't care what deal you sign. I ended up repaving the workstation. I built a new computer just to get 2017 up and running. Signposts, signifiers. You know when you build these systems, you know what's available. You know where you can go from here. So share it. Be obvious. If things are navigable, make them links. If you have methods on your APIs, use Intellisense for them. Transparency. Ambient context. Make it so anyone who's in your organization, they're logging into your intranet portals, they're walking through your building. Share information. Because after a time, people actually take pride in this. They walk in now, the first thing they like is everything green? And even, people, if someone thinks they have a problem, this is great when this starts to happen. Your users, the business people in your organization, they won't come to you and say, is there a problem? They'll go and look at the TV and check that everything is green. And if there's something red, they'll say, are you working on this? And we'll say, yeah. And if everything's green, they'll go away and they won't bother you. It's brilliant. And finally, one rule to rule them all. No matter what you're working on, you're creating APIs, you're building databases, you're doing JavaScript frameworks, you are creating user experiences. One day, the code that you write is going to be the difference between someone else going home late and pissed off and someone else having a good day, getting out on time, going home, playing with their kids. So remember them and see if you can think of ways to make them smile. Thank you very much. Please remember to use the rating system on the way out. If you liked it, give me green stickers. If you don't like it, the red stickers go in that bin on the back there. So, no, seriously. Thank you all for coming. Have a wonderful time. Enjoy the rest of the conference. I'll see you next time. Thank you.